Okay, I'm going to discuss technical details. When it boots, it starts, it loads the OS main.bin. The bootloader loads OS main.bin, this is the project file for OS main.bin. The first bit of code is right here, include OS start. So it's a flat binary, and it starts at OS start. That starts in 16-bit mode. The bootloader hands it off in real mode, and it calls some BIOS routines to change to VGA graphics mode, 640 by 480, and it calls some BIOS calls for information on memory and number of buses and stuff. Anyway, OS start calls OS end, and there's run levels, which are it's not there. It sets bits telling when it achieves certain achievements. Anyway, the last thing, the first task is called Adam. He's on the bootstrap processor. That's what they call Core 0. I like Core 0 is more clear. Anyway, and when he's done, it starts off, OS main is loaded in to the bottom 640K. Then it changes to 64-bit mode, and it loads in the compiler. And finally, after it loads the compiler, it calls, this is like the autoexec.bat file. It calls Adam1. Okay, now each task has a symbol table. You can kind of think of it like environment variables, except it can have functions, and it can have variables, and it can have classes and stuff. And Adam is the first task, and every task has a symbol table. It's a hash table. Anyway, Adam, when he starts compiling this code, these are the headers. These are the main headers for everything. Pretty much everything goes in one header file. Well, there's the classes and classes and defines are in Adam1A. The internal function headers. These are to bind the assembly routines to C++. You use extern to bind assembly label to C++, and it's a flavor of C. It's more than C, less than C++. Anyway, the compiler has some built-in functions. It doesn't have inline functions, but it has some internal functions. I can show you how to add one. When I upgrade, sometimes you have to start with the new compiler in order to compile code. Anyway, because I make syntax changes. So these are this is the third header file. These are the regular C externs. This Adam1 is compiled, and it loads all those symbols into its table. Now, line count rep. Remember we said it starts with OS main. OS main is, this is a line count rep. OS main is 25,000 lines. The compiler is a binary, and ahead of time, compiled ahead of time. It's 21,000 lines. So about 50,000 lines is compiled ahead of time. The rest of it, since Adam is the first task, he goes about loading in all those headers, and then he actually loads in, he compiles a bunch of code just in time. The reason I do it just in time instead of ahead of time is because I want to. You don't need object files, you don't need executable files, and I just like it. Anyway, so I try to do as much ahead of time or just in time as possible, and it starts in OS main when it boots. That's where this Atom1 file is, and then it hands off to Atom2, which is the next stage. That's the code that's compiled during boot. So there's about 40,000 lines compiled during boot. Atom2 is the start. It just includes all these. Some of them are directories. This is the graphics library. I do all the graphics from scratch. Anyway, bitmap has, this is the plot pixel. There's plot, I do plot triangle, plot everything. Anyway, GR screen has, well, first of all, there's a special task called the window manager task, and it updates the screen 60 times a second. It redraws everything. Invalidate rectangle doesn't help if you have a full screen video game. Therefore, I don't do invalidate rectangle. I don't care about power. This burns electricity. I like desktops. Anyway, so the window manager task calls. Okay, there's a text layer, there's a persistent layer, and there's a graphics layer. And this is all done by hand. Anyway, update Windows. This routine is called 60 times a second, and it goes through all the tasks on Core 0, and calls all terminal tasks have a document for their command line, and this goes through the update task docs. It goes through the document for the command line. It also has a you know how Windows has a mainframe and a client area. Well, in TempleOS you have an auxiliary, which is the border that there's the border text is done with the document, and then the main client area is done with a different document. You can have one window per task, and there's no difference between process, thread, and task. Everything is a task, and every task can have one window if it's on Core 0, and every task has a symbol table. Every task has a heap, and child task inherit symbols from parents. So since all tasks are children of Adam, so they get all those symbols that were loaded in at boot. Anyway, so it calls update. That writes to there's a text layer. It's not B8000. It's actually 32 bits instead of. It's got extra attributes for superscript, subscript. It's actually done with extra attributes. Anyway, so it calls, updates the document. Then task can have a draw it for drawing to a device context, a callback. Now I use this task validate because normally you wouldn't need this in a regular operating system, but this is for you to poke around with. When I had a Commodore 64, I used to modify the ROM, the basic RAM variables and stuff. This is for users to poke around with. So since you're going to be messing around with the task, I try to make it a little more robust by seeing if it gets a bad task and then bailing out. So task validate is in a lot of places. It checks task validate checks if it's in the, it goes in the lowest 2 gig addresses. It checks to see if it's tasks. The current task is pointed to by the FS segment. You have to, in 64-bit mode, you have to set it with the right model specific. Anyway, so the lowest 2 gig is special in TempleOS because, well, that's the lowest 2 gig is for code. I use only call instructions, and calls have anyway. It also puts task records on in the lowest 2 gig. Incidentally, anyway, it has a signature. It checks to see if it's in the queue and stuff. Oh, then the other thing is controls, scroll bars, and you can make controls. Those have tasks can have controls. Anyway, let me go. Memory. So the bootloader relocates itself and loads in OS main at 7C up to 3F or 3C. I have a lot of extra room in case it grows in the future. Then the page tables are at whatever that is, 1 meg. Up to I use in 64-bit mode you have 2 meg pages. I map everything identity mapped with 2 meg pages except the lowest 2 meg, which I map with 4K because it has to set the VGA is right through. Anyway, so up to the code heap is the lowest 2 gig. That's so that it can use the call relative 32 instruction everywhere. TempleOS is ring 0 only, so it never leaves ring 0 mode, so it has no protections. But it's like DOS or like a Commodore 64. Those didn't have protections. It's intentional that way because when I had a 64, I used to play around with disk blocks and play around with just for fun. You can, you know how video games entertain for 30 hours? Well, if you poke around for 30 hours, watch this document dump. FS points to the current one is FS points to the current task record. You see how it's updating live? There's live widgets